Hi everybody, I hope that you're doing well. Today's lesson is going to be on changing an equation from y-intercept form or slope-intercept form into standard form. And we've talked about this a little bit. So we know that as the previous lesson said, we can have different ways that we can write equations. And the most common way that we see a line equation or a linear equation is in this form, y equals mx plus b, where m is our slope and b is our y-intercept. That's why this is called slope-intercept form. Okay. We can actually have another way that we see equations, and that's called standard form. And there's some stuff written up here, but I don't like the upper half of the note. So if you're looking at the blank notes at home, this is the bottom of the second page. Just look at this page. So in slope-intercept form, you can see immediately what your multiplier, your slope is, your m, and you can immediately see what your constant is, your b, your y-intercept. But sometimes it's necessary for us to look at our equations in a different way, and that other way is called standard form. And in standard form, we have this where you have a times x plus b times y plus c equals 0, and this is standard form right here. And I know you're saying, but Miss C, what the heck are all of these different letters? Like in our other equation, we just have a y, an m, an x, and a b. And they're almost all the same. So here, our c is our constant. Okay. Our y is still our y. This b is just any number. Our x is still the x that we see here. Okay. And the a, again, is just a number that you can have in front of that next. So a and b can be any numbers. C, y, and x are the regular things that we see. So it's an important skill that we can go back and forth. So really the goal of today's lesson is to be able to rearrange equations so that we have y equals or we have equals to 0. And this equals to 0 is super important for standard form. So this is standard. So this is standard form up here. It's not letting me write, it's being a jerk. Okay, so let's look at this. If I have x plus y equals 3, or x plus y minus 3 equals 0, and I want to know if this is in standard form or slope-intercept form. So if I'm looking at this, I can see that everything is on one side of the equation, which means that it's standard form. And I want to rewrite this so that now it's in slope-intercept form. Okay, so I want to rewrite this so that it's y equals. Okay. So if I'm looking at x plus y minus 3 equals 0, I want y to stay on the left-hand side. I want everything else to move to the right-hand side. So I need to do those opposite operations to move them across the equal sign. So if I'm adding x on this side, I need to minus it in order to get rid of it. And if I'm subtracting 3 on the left-hand side, I need to add it to get rid of it. And whatever I do to one side, I have to do the other. So because I subtracted x on this side, that's what I need to do over here. And because I added 3 on this side, that's what I also need to do on the right-hand side. If I'm looking at my left-hand side of my equation, x minus x, that's going to go to 0. That's not a thing anymore. So those are gone. Negative 3 plus 3, that's 0. So those are gone. So now I'm only left with y on my left-hand side. So I have y, goodness gracious, y equals, and 0 minus x, well, that's just going to be negative x. And actually, we can't even gather those together. So I'm just going to write my negative x first. But 0 plus 3, that is plus 3. And now this looks like an equation that we're used to, where remember that this negative is actually that invisible 1 that sits in front of my x. So really I have a slope of negative 1 and a y-intercept or a constant of 3. Okay, so I've gone from the way that it's written like this to here, by doing opposite operations to move them across the equal sign. So let's try one more example or two more examples. So same thing. So I want to go to slope-intercept form. Basically what that means is I want everything but the y to move over to the other side. So if I'm looking here, I need to get rid of this x. I'm going to need to get rid of this -4. And at some point, I'm going to have to do something with this 2. But we're going to leave this till last because it's attached to the y. So I have a positive x. I have a -4. I'm going to have to do the opposite operations to bring them across the equal sign. So here, if I have positive x, I'm going to subtract it. My 2y stays exactly the same. If I have -4, I'm going to add it because that's the opposite. Okay, equals 0. Whatever I did to the left-hand side, I have to do to the right-hand side. And that's repeated there. If I'm looking at the left-hand side, x minus x, that's going to go to 0. -4 plus 4, that also goes to 0. So now I'm just left with 2y on my left-hand side equals 0 plus 4, that's going to be 4, and a -x. Okay. So I've gathered like terms on the left-hand side, and I've just gotten rid of everything else from the right-hand side. And my last step is I need to get rid of this 2. And I know that between my 2 and my y, I'm multiplying. So to undo multiplying, I'm going to divide. So I'm going to divide both sides by 2. Divided by 2, divided by 2. 2 divided by 2 is 1, so that leaves me with 1y, which is great. Negative x over 2, that's the same as saying 1/2 x, because remember that there's that invisible 1 here that I just can't see. Okay. And 4 divided by 2 is 2. All right. So let's do one last example here. So if I'm looking at this example right now, I notice that everything on the left-hand side is divisible by 3. So 6 can be divided by 3, 3 can be divided by 3, 15 can be divided by 3. And 0 can be divided by 3. I mean, you can split 0 things into 3 groups really easily. Everything is just going to get 0 things. So let's look at that for a second. So I'm going to just make this a little bit larger. And we're going to ignore this stuff because that's from the last question. Okay. There we go. That's gone. Our goal here is going to be moving everything over to the right-hand side that doesn't have a y in it. So I want to move this 6x over, and I want to move this -15 over. And I'm going to do that. So I have 6x. To get rid of that, I'm going to subtract it. I have -15. To get rid of that, I'm going to add it. So if I did that, whatever I added on the left-hand side, I have to add to the right-hand side. So I'm going to subtract my 6x. I'm also going to add my 15 here. And what do I notice? Well, 6x minus 6x, those go away. -15 plus 15, those go away. So that leaves me with -3y equals -6x, because there's no other x's. And 0 plus 15, that leaves me with +15. My very last step here, though, I'm looking and I notice that there's that -3 in front of the y, and I don't want that. Like, I just want y by itself. That's all we want. We want a y equals equation. So you ask yourself, what's happening between this -3 and the y? Well, that's multiplication. How do I undo multiplication? I'm going to divide it. And now I have to divide everything in the equation by -3, and just make sure that that sign comes along with it, because I don't want -y on the left-hand side. I just want y. So here, -3 divided by -3, those are going to cancel. So that goes to 1. That leaves me with just y. -6 divided by -3, that's going to leave me with 2, and the x goes beside it. And +15 divided by -3, that leaves me with -5. Okay. So it's funny because this equation here, y equals 2x minus 5, looks nothing like this equation at all. Right? They look completely different. So let's see what happens if I have 6x minus 3y minus 15. And remember I said that we noticed right off the bat that each of these things was divisible by 3. So let's see what happens if instead of rearranging first, we divide everything by 3 first. Okay, So I'm going to do divided by 3, divided by 3, divided by 3, divided by 3, just so that we can get that business out of the way. So what's 6 divided by 3? Well, 6 divided by 3 is 2x. What's negative 3 divided by 3? Well, that's going to leave me with negative 1y. And what's negative 15 divided by 3? Well, that's going to leave me with negative 5 equals, and 0 divided by 3, well, that's 0. So now if I'm looking at this equation, after I've divided everything by 3, I can start to see some similarities between the final equation that I got. Do you guys see that? Do you see how I still have a y, I still have a 2x, and I still have 5? Those numbers are still the same. Okay, so that's how we can kind of go back and forth between these. All right? So, now that we can go from standard form to slope y-intercept form, let's see if we can go backwards. Let's see if we can go from slope y-intercept form to standard form. So now I'm given a y equals equation, but I want it to look like an x plus a y plus a something equals 0. Okay, so something x plus something y plus a constant equals 0. So the goal here now is to move everything to one side of the equation. And there's two ways that we can do this. So I'm going to show you, naturally, both ways, and you guys can decide which way is better. Your first instinct is going to be moving everything to the left-hand side of the equation. So that's what we're going to do. Our first way is move to the left. So if I'm going to do that, I need to look at the signs on the right-hand side. So I have y equals negative 4x plus 1. So I want to move all of this stuff to the left-hand side of the equation. So I have y. I'll just do it on this side for a second. If I'm subtracting 4x, I have to add it. If I'm adding 1, I have to subtract it. So if I did that to the right-hand side, now I have to do it to the left-hand side. If I'm looking at the right-hand side, I notice that negative 4x plus 4, well, that goes to 0. And 1 minus 1, that also goes to 0. So I'm left with 0 on my right-hand side. That's looking like something I want. And I have y plus 4x minus 1. There's nothing else that I can group together here. That's already, all of my like terms are already collected. There's no other y's or x's that I can bundle together. No other numbers that I can bundle together. This looks good. This is what I want. But we know in math that there's always more than one way to do an equation. So the second way, remember that this, if I'm going back to my original thing where I said I want an x plus a y plus a number equals 0, well, remember that this is the same thing as this. It doesn't matter what side my 0 is on, that all means the same thing. So I could, if I'm starting with y equals negative 4x plus 1, I could make my life so much easier by just moving one thing. If I get rid of this y, then I'm left with 0 here. So let's look at that and let's see if we get the same answer. Okay, so I'm going to move my y over, and I do that by subtracting it. Y minus y, that's going to go to 0. If I subtracted y from the left-hand side, I have to subtract it from the right-hand side. So now I have negative 4x plus 1 minus y. And if I'm looking at this, even if I were to rearrange it so it looks the same, so my y's go first, I notice something. I notice that the numbers all look the same as the numbers that are above, but the signs are all backwards. And that is the final thing that we have to do here. Once you do this, if you notice that you have a negative y, you have to flip all of the signs because we never want a negative y. Okay, so I'm going to make my y positive, I'm going to make my x positive, and I'm going to make my 1 negative. And basically what I've done here, this in-between step, is I've just multiplied both sides by negative 1. And it works out exactly the same. So you guys can pick which way you want to do it. Just remember that you never want y to be negative. So let's do one more example where I want to move things over. So I have y equals x plus 3 here, okay? And I want to move everything to either the left-hand side or the right-hand side. So you're going to pick the way that you want to do it. I will show you moving everything to the left-hand side. So here's my y. Just going to leave some room here. On my right-hand side, I'm adding x. So to undo adding, I have to subtract. And I'm also adding 3, so I need to also subtract that. Whatever I did to the right-hand side, I have to do to the left-hand side. Okay? So here everything is neatly over on my left-hand side here. I notice that x minus x is 0, and 3 minus 3 is 0, so that leaves me with 0 on this side. Now I'm done. Okay? You also just want to do a quick double check that your y is positive, and it is, so that makes me extremely happy. The same thing happens here in this question. Okay? So the same thing is going to happen here in this question. And actually, it just becomes really easy. I know that this fraction is going to make you guys kind of take a double take, but we're just going to switch things over to the other side. So I'm going to leave some room again. If I'm subtracting 2 over 3x on the right-hand side, I need to add it to get rid of it. If I'm subtracting 2, I'm also going to add that. Whatever I did to the right-hand side, I have to do to the left-hand side, so I'm going to add 2 over 3x. I'm also going to add 2. I notice that negative 2 over 3x plus 2 over 3x, that's going to go to 0. And negative 2 plus 2 also goes to 0. So here's my equation. Okay. Now, sometimes we don't really like seeing fractions, so what we might do is multiply everything by 3 to get rid of that fraction. So this could also look like 3y plus 2x plus 6 equals 0. And all I've done here is multiplied everything by 3. And that's just because that's what the bottom of that fraction is. Okay. So this is standard form and slope-intercept form. Both are really important for when we're trying to figure things out. So if I need to figure out where my intercepts are, I'm going to use standard form. So if I need to figure out where my intercepts are, this is usually the form that I use. But if I need to figure out what my slope is right away, then I might use slope y-intercept form, okay? And we're going to take another look at this in the next lesson. I hope you guys are doing well.